And then 74, I guess we're trying to trap you. At the cathode, we know that the oxygen should be reduced. And so we've got O2, 4H plus 4 electrons going to 2H2O at the cathode. So the question's expecting you to have thought about that, and that's why A is the answer. But surely that's just telling you for every mole of oxygen you would consume 4 electrons. There's nothing in the question about talking about 1 mole of oxygen. So it would only be 4 mole if 1 mole of oxygen had been supplied at the electrode. So it's not that. Double the mole of electrons produced at the anode, that would not make sense in any sort of circuit that you looked at. Let's put it back in the normal situation. For every electron that comes out of there, there must be 1 electron going in there. So for every mole of electrons that comes out of the anode, there must be 1 mole of electrons going in at the cathode. So double the mole of electrons produced at the anode does not make sense. Half the mole of electrons produced at the anode does not make sense. Same as the mole of electrons. Yep, that's the one we want. Answer D. 74. 75. Yes, I think I wanted to stop there. This is a nice acid electrolyte, hydrogen oxygen fuel cell. You say, yippee, I know exactly what's going to happen here. I don't have to be confused by it might be an unfamiliar situation. It's not the usual two beakers with 2 electrodes and a salt bridge. It's set up in a different way, but you're given the direction of electron flow. So you know, without even looking at the question, that's got to be the negative electrode and that's got to be the positive electrode. Electrons will always go from where oxidation occurs, so there must be oxidation giving up electrons. There must be reduction accepting those electrons. That therefore means the fuel must be coming in here, and therefore that's got to be hydrogen because it's a hydrogen-oxygen fuel cell. Reduction occurs at the cathode, so we know that's going to be the cathode. We know that's going to be the anode, because of our little red cat mnemonic. So the reactant X is going to have to be oxygen. That's fairly easily deduced. So write the equation that occurs at electrode 1. That's the cathode. So we get it straight from the electrochemical series. We know exactly where to go. At 1.23, we've got O2 plus 4H plus. You just have to copy that directly out. Don't forget to include symbols of state. It would be an unlikely marking scheme to pick on symbols of state there. So I'm not going to write that. You can fill that in later. This is definitely a question worth filling in. I'm just going to give you a guide. The equation at reaction 2 is going to be the oxidation of the hydrogen, but which oxidation of hydrogen? The one at 0.00, because that's the one that gives you H+. So that's going to go that way. That's going to go that way. Note we've got a favourable diagonal, a favdiag, and also we can see that if we were predicting the voltage it should be 1.23 volts. But we've got to get those half equations correct. Make sure you work through this question. That is definitely a VCAR exam style question. Check your answers when you get it, but it should be easy as long as you know which half reactions to choose from your electrochemical series. So what's the overall cell reaction? I don't even have to add the 2 halves. I know it's going to be hydrogen reacting with oxygen to give you water. Make sure that's a balanced equation, but you should get that if you accurately add the 2 halves. Let's keep going. Describe the change in pH. Oh, bother. Okay, if we're going to describe the change in pH, we need to know what's happening to the H+. pH is the power of hydrogen ion. This used to be a pretty fair question, probably less likely now. I think you don't have to do any calculations involving pH anymore. That's been taken out of the syllabus. So at this stage, we just need to know if the H+ goes up, the pH will go down. If the concentration of H+ goes down, the pH will, sorry, the other way around. If the H+ concentration goes up, the pH will be going up. Down. This is how, let's just get this right. If I had pH equals 7, the H+ concentration would be 10. 10 to the minus 7 molar. That's pretty low. If the pH was 1, the H plus concentration would be 10 to the minus 1. You should definitely have covered that in year 11. And if the pH was 10, say, the H plus concentration would be 10 to the minus 10 molar. So if we're interested in what the pH is doing, we have to know what the H plus is doing. So I can see from that relationship, if the H plus concentration is getting bigger going down that way, then the pH is getting smaller going down that way. So pH decreasing if the H plus concentration increases. See that from the numbers. So don't get muddled about that. Describe the change in pH. We would have to know what's happening. Electrode 1, we said, was where the oxygen is being reduced. O2 plus 4H plus. All right, let's put it in. Goes to 2H2O. So I'm using up H plus. So in terms of describe the pH at each electrode, so that was electrode 1. So let's do the answer for that by considering if it's using up H plus concentration decreases. Decreasing pH going up that way, going the opposite way to here, decrease. Going up, then the pH is increasing. So at electrode 1, if the H plus decreases, pH increases. That's easy for your brain to get that the wrong way round. Make a mental note, in the pressure of an exam, everyone knows pH is a measure of acidity. H plus decreasing means it gets less acidic. It is so easy to say, oh, it's less acidic, the pH must be lower. No, you can see from the numbers the pH is increasing. There's an inverse relationship between the concentration of H plus and the pH. So let's look at that again. When we look at the oxidation of the hydrogen, our E0 table, our electrochemical series tells us H2 is going to be oxidized to H plus. The H plus concentration around that electrode will be increasing. Mental note, double check your definition. So easy for your brain to say pH is a measure of the H plus. If the H plus is increasing, your brain will be screaming at you, the pH is increasing. No, look at the numbers, inverse relationship, the pH will be decreasing. Make a mental note, that's an easy mistake to make. If you have to talk about pH, my gut feeling is possibly you won't. That's been downplayed in the new study design. But I wouldn't count on it. You're supposed to have covered it in year 11, and that's a reasonably easy question that is easily got the wrong way round. Just check why. I'll just go through the logic again. Under the pressure of an exam, your brain will say pH is a measure, is related to the H plus concentration. Stands for power of hydrogen ion concentration. So you know it's something to do with the H plus, and your brain will be screaming, if the H plus increases, the pH will be increasing. Wrong. The pH will be decreasing. Easy mistake to make. Let's move on. All right, we want to know which way the chloride ions will go. They are anions. So anions will go to the anode. We agreed that we had oxygen here, so that this is the, so what did we decide on? Better go back and check. We decided that the fuel was coming in from the right. That's where the oxidation was occurring. So we had our oxidation here. Scrub that. That's the hydrogen coming in, being oxidized. And so that's the anode. But we had that on the original diagram, put it on again. Anions will go to the anode, so your Cl minus ions in the electrolyte are going to be heading that way, heading from electrode 1 to electrode 2. And what are the functions of the electrodes? Important question. Now obviously they have to conduct electricity. A VCAR exam is not going to want probably more than one function, at most two. So conduct electricity may well get you the mark if there's only one mark. There are no half marks, but they might expect a little bit more than that. So if it's conducting electricity, they are also keeping reactants separated. Remember, the whole principle of any galvanic cell is that if you allow the reactants to mix directly, you will just get heat from an exothermic reaction. You won't get any electricity. If you want to get electricity from the chemical energy that's available, you have to stop the reactants from meeting. So I think you can see from the diagram, the electrodes are stopping the reactant X meeting reactant Y, the oxygen meeting the hydrogen. So that's one of their functions. And then we would often find that in this situation, it's very slow. You don't get much current, so that's annoying. So how do we increase the rate of the reaction? Well, I guess we could heat up the cell. That would speed things up, but that would probably be inconvenient. It would be really helpful if the reaction's occurring at the electrodes, then it makes sense, make the electrodes out of some sort of catalytic material that speeds up the reaction. So we want the electrodes to act as catalysts. Now that's a little bit memorisy, but I think that's probably one of the things that you would memorise just in case you got a question like that. It's unlikely you would have to come up with 3 functions. It's almost certainly only 1 mark for that question. I suspect they would probably give you a mark for any of those 3, but it helps to have a few facts up at your fingertips.